In this next question from the chapter of trigonometric identities, we are given LHS as cosec A minus sin A into sec A minus cos A, and we have to write it. We have to prove this is equal to 1 plus tan A plus cot A. Now, unlike most of the questions of trigonometric function, here will not be proving LHS as RHS. Instead of that, we'll be simplifying both LHS and RHS. Right. Now, why did such thoughts would come to your mind? Because you can see our LHS is in terms of, it has all trigonometric ratio involved. You can see sine, cos, sec, cosec, tan, cot, all 6 trigonometric ratios are there. And what do we know? That sine and cos are 2 such trigonometric ratio which has relation with all of them. Means I can write tan in terms of sine cos. I can write cot in terms of sine cos. I can write sec in terms of cos, and I can write cosec in terms of sine. And that is the reason why in most of the questions like this, we convert them in the sine cos form. Now, let's say if I write the LHS, as I said, I'm going to write them in terms of sine and cos. So using this cosec, which is equal to 1 by sine. And let's say, first I should write it and then we'll discuss it. Now, if I write LHS, which is, I'm writing cosec as 1 by sine, as I said earlier. Cosec is 1 over sine A, and this minus sine A is copied, enclosed in a bracket. And then we have sec A, as I said, sec A can be written as 1 by cos A. So I'll be writing this as 1 by 1 over cos A minus cos A. Now, after that, I'm going to take LCM. So if I take LCM, clearly the LCM is sine A here. And this will be 1. Sine A multiplied by sine A is sine square A is equal to, the LCM is cos A here. And cos A multiplied by cos A is cos square A. Right. Now, what you can see that we can simplify it further. As you know that I can write from this identity, the first one I can write 1 minus sine square A as cos square A. So that's what I'll do here. I'm writing this 1 minus sine square A, right? This is 1 minus sine square A. By that I mean to say this one, right? This is 1 minus sine square A can be written as, say, cos square A. And similarly, I can write this 1 minus cos square A as sine square A, right? So this is into sine square A. Well, I should have written this remaining part as it is, and there is over here is sine A, and this is cos A. Now we can see it can be reduced. I can cancel sine A with because there is 2 sine A into sine A, so I cut one sine A, and cos A, this is cos A into cos A. So at the end we get cos A into sine A. This is what we got. The simplified form of the LHS. As we know, we cannot simplify it further, so we should leave the LHS as it is. We should follow these steps in case when we have. Right, let me first write. This is LHS. Now I'm going to expand the RHS here. As you can see, RHS where we have as 1 over tan A plus cot A. As I told you in the beginning, we have all trigonometric ratio can be written in terms of sine and cos, and that's why we are going to convert this tan as sine by cos and cot as cos by sine. So let's say if I do so, this is sine A over cos A plus this is cos A over sine A. Now continue to simplify the denominator. I can see LCM is product of these two. So it's cos A into sine A, or maybe you can write sine A into cos A. So sine A multiplied by sine A is sine square A. And cos A multiplied by cos A is cos square A. So we have written this in the simplest form as far possible. Now say further, what you can observe here that this sine square A plus cos square A is 1. The sine square A plus cos square A is 1. Once again, this is sine square A plus cos square A is 1. That is from the first identity, this one. So I'm going to write this sine square A. This is 1, and sine square A plus cos square is 1. That divided by sine A over cos A. That divided by sine A over cos A. As you know that multiplying is same as, dividing is same as multiplying with the reciprocal. So let's say I wrote 1 and dividing by this is same as multiplying with the reciprocal. So I can write a sine A into cos A by 1. So what we got this finally as sine A into cos A. Well, this is what the LHS and this being the RHS. So we say LHS is equal to RHS and hence verified.